Your Ford's turbocharger is being slowly strangled, and the cause is sitting right in your garage. Most owners are making oil mistakes so basic that it physically hurts me to diagnose them after 15 years as a Ford technician. I'm talking about errors that cost people $3,000, $5,000, even $7,000 in turbo replacements, intercooler cleans, and engine rebuilds. Problems that were completely 100% preventable. The turbocharger on your EcoBoost Ford spins at up to 150,000 revolutions per minute. The only thing standing between those bearings and catastrophic failure is a thin film of clean, properly pressurized oil flowing through lines no wider than your pinky finger. When those lines get clogged, the turbo runs dry. A turbo running dry does not give you a warning light or a polite request to pull over. It destroys itself within minutes, sometimes seconds, and often takes surrounding components with it. Today, we are covering the 7 oil mistakes that are quietly clogging those turbo oil lines right now in Ford trucks and SUVs across the country. Mistake number 4 is so common that I see it almost every single week in my shop, and the owners are completely blindsided every time. Mistake number 1 is the one Ford's own service documentation warns against, yet dealership service lanes across the country let it slide every single day. Stay with me, because what you are about to learn could save you from the most expensive repair bill your Ford will ever generate. Let's talk about the worst oil change interval mistake most Ford EcoBoost owners are making right now. This is mistake 7, trusting the oil life monitor without understanding what it actually measures. Ford's intelligent oil life monitor is not measuring your oil. Let me say that again because it matters. The system does not have a sensor that physically tests your oil. It is a computer algorithm that estimates oil degradation based on engine temperature cycles, RPM patterns, miles driven, and load conditions. It is sophisticated, but it is an estimate, and it has a critical flaw for turbocharged engines. The turbocharger creates heat conditions that the oil life monitor was not specifically calibrated to account for in the same way a laboratory oil analysis would. When your EcoBoost shuts down after hard driving, the turbo keeps spinning on nothing but residual heat and the last oil that coated its bearings before oil pressure dropped. This is called heat soak. During heat soak, oil temperatures at the turbo bearings can spike to 400 degrees Fahrenheit or higher. At those temperatures, oil begins to break down at the molecular level, forming varnish and carbon deposits that the oil life monitor never registers as degradation, because it is based on operational patterns, not actual chemical composition. Owners who wait until the oil life monitor hits 15 or 20% before changing oil are running degraded oil through their turbo bearing journals for thousands of miles. That degraded oil deposits varnish inside the tiny oil feed passages that supply the turbocharger. Over time, those deposits narrow the passage, restrict flow, and starve the turbo of lubrication during the moments it needs it most. For EcoBoost F-150s and Edge STs used for towing or spirited driving, I recommend changing oil every 5,000 miles, regardless of what the monitor says. The monitor is a useful tool for light-duty drivers, but for anyone working their turbo hard, treat it as a secondary reference, not a final authority. Mistake 6 is one that has single-handedly caused more sludge-related turbo oil line blockages than any other factor I have seen. It comes down to using conventional oil in an EcoBoost engine. Ford's EcoBoost engines, the 2.3-liter, 2.7-liter, 3.5-liter, and 1.5-liter, are specifically engineered and factory filled with full synthetic motor oil. The owner's manual specifies Motorcraft Full Synthetic SAE 5W30 or an equivalent full synthetic. That word equivalent carries more weight than most people realize. Conventional oil and synthetic blend oil have fundamentally different molecular structures. Conventional oil is refined petroleum with molecules of varying size and shape. When those irregularly shaped molecules are subjected to the extreme heat cycling a turbocharged engine creates, they break down unevenly, Some molecules oxidize and polymerize, forming sludge and varnish far faster than synthetic molecules do. The result is a dark, thick contamination that accumulates in the lowest flow areas of your oil system. And the lowest flow area with the smallest passage diameter in your EcoBoost is the Turbocharger oil feed line. I have pulled turbo oil feed lines from EcoBoost engines that had been run on conventional oil, and the restriction was visible to the naked eye. The passage that should be fully open had narrowed to a fraction of its original diameter, coated with baked-on black sludge. The turbo on that truck was already showing shaft play when I checked it. The owner had saved maybe $20 per oil change for 2 years and was looking at a $4,200 turbocharger replacement. Use full synthetic every single time. No exceptions, no compromises. Do not use what is on the shelf because you could not find the right kind. The cost difference over a year is around $60. The cost of a turbo replacement is $2,000 to $5,000, and that is before labor. Mistake 5 is something I see at quick lube shops constantly, and it makes my blood pressure rise every time, using the wrong viscosity oil. Ford's EcoBoost engines are precision machines designed around specific oil flow characteristics. The 2.3-liter EcoBoost in the Mustang and Ranger calls for SAE5W30. The 2.7-liter and 3.5-liter EcoBoost in the F-150 also specify SAE5W30. The 1.5-liter in the Escape and Bronco Sport calls for 0W20 in certain model years. These are not suggestions, they are engineering specifications. When a quick lube tech grabs a 5W40 or a 10W30 because it is what is loaded in the machine that day, the consequences for your turbo are real and measurable. Oil viscosity directly controls how quickly oil reaches the turbocharger bearings on cold start. A thicker than specified oil takes longer to flow through the narrow turbo oil supply passage during those critical first seconds of startup when bearing wear is highest. A thinner than specified oil does not maintain the film thickness needed at operating temperature to protect bearings spinning at 150,000 RPM. Either deviation from spec accelerates turbo bearing wear and creates conditions where varnish deposits form more readily inside the oil lines. Always verify the oil viscosity before you let anyone change your oil. Look in your owner's manual, confirm the spec, and watch the tech pour in the correct product. If you are at a quick lube and they do not carry the specified viscosity, leave and go somewhere that does. This is not the place to make substitutions. If you are finding this valuable, go ahead and hit that subscribe button and the notification bell right now, because we are about to cover the 3 oil mistakes that cause the most direct, irreversible damage to turbocharger oil lines in Ford EcoBoost engines. Mistake 4 is one I diagnose almost weekly, and owners are shocked every single time they hear it because it seems so counterintuitive, overfilling the oil. More oil seems like it should be better, right? More protection, more lubrication, more safety margin. The reality is the exact opposite for turbocharged engines, and the damage it causes is both severe and often not covered under warranty because it is considered owner-caused damage. Ford EcoBoost engines have a precise oil capacity specification. The 2.7-liter EcoBoost holds 6 quarts. The 3.5-liter EcoBoost holds 6 quarts as well. When oil level exceeds the full mark on the dipstick, the crankshaft begins to contact and whip the excess oil as it rotates. This aeration process introduces millions of tiny air bubbles into the oil. Aerated oil is foam, and foam does not lubricate. Aerated oil that gets pumped through the turbocharger oil supply line reaches the turbo bearings as a frothy mixture that cannot maintain the protective film needed at high RPM. The problem gets worse. Aerated oil also has a lower flash point than clean oil, meaning it is more prone to oxidation and thermal breakdown at the exact temperatures your turbocharger generates. The resulting breakdown products, fine carbon particles and varnish precursors, are small enough to pass through the oil filter, but sticky enough to adhere to the walls of the narrow turbo oil feed passage. Over time, they accumulate and restrict flow. I have seen overfill damage create turbo oil line restrictions that required complete line replacement and turbo rebuild, all because someone added an extra half quart thinking they were doing their engine a favor. After every oil change, check your dipstick twice. The oil level should be between the minimum and maximum marks, ideally at or just below the maximum. If it is over the full mark, drain some out. That extra oil is not protecting your engine, it is working against it. Mistake 3 goes against everything your instincts are telling you on a cold winter morning. Not letting the turbo oil pressure equalize before driving hard after startup. This mistake is destroying turbocharger bearings in EcoBoost Fords at an alarming rate, and it is entirely preventable with a simple change in habit. When your Ford sits overnight, gravity pulls oil out of the turbocharger housing and down into the oil pan. The turbo bearing journal, the precision gap between the spinning shaft and the bearing housing, drains nearly dry. When you start the engine, it takes several seconds for the oil pump to build pressure and push oil back up through the feed line and into the turbo. During those seconds, the turbo shaft has no oil film protecting it. If the engine is at idle, turbo shaft speed is low, and the brief oil starvation, though not ideal, causes minimal damage. But if you start the engine and immediately rev it hard, accelerate aggressively, or jump on the highway, the turbo spools up to tens of thousands of revolutions per minute with dry or nearly dry bearings. The metal-to-metal contact during those seconds removes material from the bearing surface and from the shaft itself. The metal particles generated by that contact get carried in the oil and circulate through the oil lines, where they can lodge and accumulate in the tight bend where the turbo oil feed line attaches to the compressor housing. The rule is simple. After a cold start, let the engine idle for 60 to 90 seconds before driving aggressively. You do not need to sit in your driveway for 10 minutes. Modern synthetic oil flows quickly even in cold temperatures. 60 seconds is enough for oil pressure to fully stabilize and for the turbo bearings to receive proper lubrication. Then drive gently for the first 1 or 2 miles before putting any significant load on the engine. This single habit change costs you nothing and extends turbocharger life by tens of thousands of miles. Mistake 2 is one that Ford technicians talk about in hushed tones because it involves a factory design characteristic that causes a very specific and very expensive failure pattern. It comes from not idling down the engine before shutdown after hard driving. This is called turbo cooldown, and skipping it is one of the fastest ways to bake carbon deposits into your turbo oil supply line. Here is the physics. When you drive hard, tow a trailer, or run your EcoBoost at sustained highway speeds, your turbocharger gets extremely hot. The exhaust turbine wheel sits directly in the exhaust stream and can reach temperatures exceeding 1,000 degrees Fahrenheit. The oil flowing through the turbo bearings absorbs some of that heat and carries it away, which is part of what oil does in a turbo system. But when you shut the engine off immediately after hard driving, the oil pump stops. No more oil is flowing through the turbo bearing. The residual heat in the turbine housing has nowhere to go, so it soaks into the bearing journal and into the oil that is trapped in the supply line and bearing passages. That oil, sitting static in a 400 to 500 degree environment with no flow to carry heat away, bakes. The lighter fractions evaporate and what remains is a carbonized varnish coating on the interior of the turbo oil passages. Do this repeatedly and those passages narrow progressively, oil flow decreases, and turbo bearing temperature increases because less cooling oil is reaching it. The cycle accelerates until the passages are critically restricted or the turbo fails outright. The fix requires nothing more than your foot on the brake for 60 to 90 seconds. After any hard driving, towing, or extended highway running, let the engine idle for at least 60 seconds before shutting it off. This keeps the oil pump running, maintains flow through the turbo bearings, and allows residual heat to dissipate safely. If you have been shutting your EcoBoost down immediately after driving hard for years, it is worth having your turbo oil feed line inspected. A restricted line can sometimes be cleaned professionally before it progresses to turbo bearing failure. Catching it early is a $200 service call. Missing it is a $4,000 turbo replacement. Mistake number 1 is the oil mistake that Ford's own service documentation specifically calls out, that dealers have standing instructions to address, and that owners overwhelmingly ignore because they do not understand how catastrophically it affects turbo oil line condition. The number 1 oil mistake destroying EcoBoost turbos is using oil that does not carry the API-SP or Ford WSS M2C946B1 specification. Ford updated the oil specification for EcoBoost engines to require oil meeting the WSS M2C946B1 standard, which corresponds to API-SP with the resource-conserving designation. This specification exists because Ford engineering identified that earlier generation oils allowed higher rates of low-speed pre-ignition, a phenomenon where the fuel-air mixture ignites before the spark plug fires in turbocharged direct injection engines. The specification also mandates a specific low-speed, high-temperature viscosity performance that ensures the oil maintains adequate film thickness in the turbocharger bearing journal during the conditions most likely to cause wear and deposit formation. Oils that do not meet this specification, even high-quality full synthetic oils from reputable brands, may lack the precise additive chemistry to resist the thermal cycling that EcoBoost turbo oil is subjected to. The additives that prevent varnish formation in the turbo oil supply line and drain back passage are specific to this spec. Without them, thermal oxidation byproducts accumulate in the oil line at a faster rate, and the narrow turbo drain backline, which relies entirely on gravity to return oil from the turbo to the sump, is particularly vulnerable. If the drain line restricts, even partially, oil backs up in the turbo center housing, overheats further, and creates exactly the conditions that lead to catastrophic bearing failure. Every time you buy oil for your EcoBoost Ford, look for 2 things on the bottle. First, full synthetic, not synthetic blend. Second, API-SP or the Ford WSS M2C946B1 approval printed on the container. Motorcraft Full Synthetic 5W30 meets this spec. Several other brands do as well, but plenty of oils on the shelf at your local parts store do not. The price difference between a compliant and non-compliant quart of full synthetic is often under $1. The difference in protection for your turbocharger oil lines is the difference between a $4,000 repair and none at all. Your EcoBoost turbocharger is one of the most performance-critical and expensive components in your Ford. It is also one of the most maintenance-sensitive. The 7 oil mistakes we covered today, trusting the monitor too blindly, using conventional oil, using the wrong viscosity, overfilling, skipping cold startup idle time, shutting down hot without letting the turbo cool, and using non-spec oil, are each capable of causing turbo oil line blockages and bearing failures that cost several $1,000s to repair. Together, they can destroy a turbocharger in as few as 40,000 miles on a truck that should have given you 200,000. None of these fixes cost you money. Using the right oil is the same price or cheaper in the long run. Waiting 60 seconds after startup and before shutdown costs nothing except a small change in habit. Checking your oil level after a change takes 30 seconds. These are small disciplines with enormous consequences for the life of your engine and your turbo. Go out to your Ford today and check 2 things. Pull your dipstick and verify your oil is at the correct level, not over the maximum mark. Then check the bottle or receipt from your last oil change and confirm it was full synthetic meeting API-SP. If either of those answers concerns you, take action now before the damage compounds further. If this video helped you understand what is really happening in your turbo oil system, subscribe and hit the notification bell, because we cover Ford-specific mechanical knowledge you'll not find in a generic repair manual. Drop a comment telling me which of these 7 mistakes you have been making without realizing it, and share this with another Ford EcoBoost owner who needs to see it before their turbo does. I will see you in the next one.